Franklin Hodge have been going for over 50 years. They are one of the UK's largest manufacturers of sprinkler tanks and tanks in general. We make a range of cylindrical sprinkler tanks and innovative rectangular ones that go into basements and all sorts of confined spaces. We also make other tanks for other purposes, including glass tanks for drinking water and other sort of agricultural products and waste. So Franklin Hodge also have a range of silos and cooling towers that extend our manufacturing capability. From a point of view of the robot, we were particularly interested in the pipework that we supply along with our cylindrical tanks and cooling towers. For the most part, that is mild steel and then galvanised after we manufacture. So the big issue that we had from a production point of view was we have a huge range of pipework. So we have everything from 50mm up to 500mm in diameter. And we have a situation where our pipework goes through a cylindrical tank wall.
So the products that we are welding are all pipe-based. So they could be straight lengths of pipe, they could be elbows, they will have flanges on them. They may not have flanges on them. There are some special shapes which we use with certain types of tanks. As previously been described, the variance in what we make is very, very large, probably in excess of 200 different models and types. I think the last time I looked on the system, there was 130 models currently on the system, and that is not finished by a long way.
So the issue that we were trying to solve was, how do we get a consistent and relatively lower cost weld onto a set of products that aren't set up for robot welding. So we wanted the consistency of a robot and we wanted the flexibility of a human, and how did we actually go about that? That's where we came across the Abagy solution, and what that offered us is the ability to get that programming of each unique part in a live environment and take out the manual element of programming a robot, where it would have been great for thousands of similar components, but not great for a line that literally might be one product, then the next different product, then the next different product, and then the next different product.
So having been given the project brief, I then started to look around for what was available in the market. As I said earlier, I've had some experience with a previous welding cell, and I knew that the time taken to program a part was not anything that we could use. So I was looking for an automated process. I found several automated processes. Most of them were American, but they were really for straight pipe and very, very little opportunity to do specialized parts. When I came across the Abagy system, I could see immediately that flexibility was built into it. It was a root of the whole system, which made it very, very attractive to start off with. Hence, I made some inquiries with Abagy, and after some brief conversations, it was fairly obvious that it was a route that needed investigation.
So when we started looking at a solution for this, the main drivers, we knew that particularly welding of pipe work, the consistency was really, really important, and that's where my mind went immediately to, let's go and get a robot to do it, because that gives you the consistency. The difficulty we then had is obviously the flexibility. So what we were then looking for is a solution that could marry up the flexibility of needing one-piece flow versus the requirement for that consistency. When we found the Abagy system, what that actually does is it gives us that mix of the two. So how that works for us is we supply the system a 3D model of the pipework that we want to manufacture. We supply that into the Abagy software. The Abagy software then checks that for what the welds might be, and we say that's the correct welds that we want to operate. These are the parameters that we want it to operate by, and effectively simulate that, check that everything is okay, and then when it's okay, we press go and we can walk away. And from an operator point of view, the robot is now working on the component, and he can be preparing the next component or working on the thing. So in terms of the labour input that goes into a project, it's automatically reduced because we haven't got somebody standing there and doing the work while the weld's being applied. What we do from a daily operational point of view is we look at our schedule, and our schedules are quite flexible because of the nature of our customers' business. We then kit up effectively the next jobs for manufacturer. So the pipe will get prepped on the saw, the flanges will all be cut and taken from stock, and along with any bought out flanges. That then goes into the robot cell, where we firstly tack up in a separate area. So we'll tack up just to make sure that assembly is correct. Then those get put onto a jig, and then the jig gets inserted into the cell. And that's when the operator will then run the scans, load the program, load the model, check that everything's okay, press go, and then he can go back to preparation. And that's so effectively kitting up the next job. So our full cycle is then effectively tacking up and preparing the next job while the robot is doing the job of the final weld. Then once that weld is complete, obviously we're taking that component out of the cell, putting the new component back into the cell, and the cycle just repeats itself from there. So we were previously outsourcing that work. So to be able to bring that into our own fabrications, obviously, and we're able to, increase our margin effectively and reduce our costs on the product.
We had always had these parts made by a subcontractor, and the decision was made that we were to try and bring that in-house. So there were two issues to overcome. One of them was a learning curve on how to make pipe work. And the second one was, how do we then take that learning curve and apply it to a robot cell that didn't exist? I have had some experience with a previous welding cell. I worked very closely with Abagy to sort out how we would lay the cell out. I started with some initial ideas, which were passed backwards and forwards, Abagy explaining the bits they liked, the bits that they thought could be improved, and between us we came up with that. We also took on the function of designing all the welding fixtures. We felt that would be easier from our point of view because we have the facilities in-house, and we also needed that skill base going forward for products that we don't know exist yet, but will probably turn up over the next year, 2 years, whatever, which is the advantage of the Abagy system. It allows all this flexibility with no downsides.
So I think in terms of key success parameters, we had a good open relationship with Abagy about what was required and how it was going to work, and how we felt it would work, how they felt it would also work, and what are the best ways of putting that together. So working closely, we developed a cell that would actually work, including us changing actually from originally having a robot that we had here, so which would have been a post-fit activity for Abagy, and a two-axis positioner, to moving a whole, effectively a whole solution from Abagy and getting a longer reach robot and a single axe positioner, because that was a better technical solution to deliver what we wanted to deliver. So yeah, in terms of key things, working closely together, having a key eye on what it was we really wanted as a result, and making sure that delivered both in terms of technically and financially. So moving forward, we're looking at what other things that we can do with that type of technology. So we also weld a lot of our ladders and platforms, and we weld an awful lot of beams for our rectangular tanks. And both of those products have a fair degree of flexibility and adaptability in the components. So they're bespoke by project to an extent, but there's enough consistency in there that we can model another cell around that. And so now we're looking at how can we extend that capability throughout further parts of the range with either a second cell or an adaptation of the first cell. We've also extending our offering on pipework from just the connections to the tank to further runs away from where the tank base is, from the cooling tower is, so that we can offer a wider solution to our clients.
So the solution has been in now just over a year. There has been teething problems, but that's the same with all engineering solutions. And Abagy has been at our side every step of the way with every problem that we've had, whether it be jigs, whether it be welding, whatever it is. We have an easy way of communicating with them, and we normally get a solution within hours, sometimes minutes.
And since then, the support has also been great. So if we've ever run across problems with software or bits and pieces of our understanding of training, then all of those have been worked through really quickly with the guys. So it's been a very productive relationship, and yeah, we're looking forward to doing more work.